If you were going to take a biology class, it's pretty easy to describe what biology is. It's a study of life, so you know you're going to be dealing with plants, animals, cells, people, all of that stuff. If you take a chemistry class, it's also pretty easy to describe what that is. You're dealing with chemicals, you're dealing with the periodic table, you're dealing with elements and acids and bases and all that. You can even imagine what the labs are going to look like. But if you're taking a physics class, it's sometimes a little bit harder to describe what physics is. You can say it's the study of the physical world, but that doesn't really get at what you're going to be doing in class or what you would be studying. You can say all these other things that are very vague. It's the science of the very large and the very small, the very weird and the very commonplace, the very fast and very slow, but I just sound like I'm saying it's the science of everything, and that's not helpful. So in this video, I want to show you some of the things that physics is. One thing physics is the study of motion. That can be very simple or a very complicated thing, because if you just have something moving in a straight line like this, and there's no forces acting on it, it'll always go at that constant speed, or as we sometimes say, a constant velocity. But as soon as you add any other sort of complication to the system, like if I were to tilt this ramp a little, now it's gonna speed up as it goes down the ramp and slow down on its way up, and there's a little turnaround in between. So that's when you add acceleration to the motion, and it can get complicated pretty quickly. But even this is just motion in one direction, or as we sometimes say, motion in one dimension. It's a little bit more interesting, and there's more we can do with it if we add the second dimension. So instead of having something moving in a straight line, it can be moving in a plane. And I'm very good at catching. Something that we'll look at in this class, we'll look at parabolic motion specifically. So that's when you have two directions going on at once. So it's moving up and down, and it's also moving side to side. It's difficult to imagine talking about motion without talking about forces. So when we think about forces, we end up thinking about weights, we think about scales. This is a force sensor, which is also a scale. And if I place this weight on this spring scale, it weighs in around 5 newtons. This is measuring in newtons. This is a 500 gram weight, and it turns out that 500 grams is very close to 5 newtons. So here's the thing. So if this weighs 5 newtons, that means it takes 5 newtons of force to lift it. But what if I have a pulley system? Pulley systems are supposed to make it easier to lift things, right? And that was 5 newtons before. Let's see how many newtons it takes to lift it now. Looks like we are still hovering at 5. Okay, so setting up a pulley system isn't automatically helpful. It matters how you set up your pulley system. Let's try something different. So this time I've actually got the pulley attached to the weight instead. If I attach my scale here, all right, now we're hovering around 2.5 newtons. All right, so the thing that's going on here is now there's actually 2 strings working together to pull the mass up. And the cool thing about studying physics is that you don't even need a pulley or strings with you to be able to analyze systems like this and be able to figure out which ones are going to be helpful to you and which ones aren't. Another fun thing about physics is once you've gone through a bunch of stuff about motion, you can start dealing with circular motion. So not just parabolas or straight lines, but motion in a circle or things spinning. This is a really fun demonstration. You may have seen it before if you've ever watched somebody ice skate or like figure skaters. Check it out. Okay, got this turntable down here. And if I have my arms out to my side carrying these weights and I get myself spinning, let's see if we can do this. And then I pull my arms in, I suddenly start spinning faster. Watch again. Start off slow, and so that has to do with the angular momentum that you get. When you have something with your arms out at your side, it's a little bit harder to get yourself spinning and keep yourself spinning. When you pull your arms in, it's easier to spin, and in order to maintain that angular momentum, you end up spinning faster. It's very cool. I just used a keyword momentum there, and if you've heard that word momentum before and you've thought about momentum and energy transfers, maybe you've seen these before. This is called a Newton's cradle. And what people usually do with the Newton's cradle is they lift up one ball on one end, And somehow, because of the way energy and momentum get transferred, the ones in the middle, they know to stay still, and the ones on the end keep on moving. So always it's one at either end that's moving, and the ones in the middle stay at least pretty still. But have you ever tried lifting up two? If you lift up two, now two go on each end. And it's just the middle one that stays still. And if you lift up three, now you get three going on each end. And the middle one doesn't get to stay still, it has to keep moving. And if I flip four, and now the middle three have to keep moving. And if I lift up five, it is not very exciting. And once we've worn out forces and energy and momentum and the basic kinds of motion, you know, straight line, parabolas, circles, there's one more fairly simple kind of motion that we can deal with, which is wave motion. And waves can do some interesting things. So what I have here is a spring, and I can just send a wave pulse, which gets reflected back because it hits that clamp over there. But the other thing I can do is make something called a standing wave. And a standing wave is where we have a wave that almost seems to hold in place. There's a little bit more going on than that, but what it'll look like is there's going to be certain places on the spring where the spring is barely moving at all, and other places where it's moving a lot. The simplest kind is just like this. You know, if you play jump rope, that's basically what you get. The middle of the spring is moving a lot, the edges aren't moving as much. That one doesn't look very good. But if I go up to the next harmonic and start shaking the spring a little faster, there we go. Now we see the center of the spring is barely moving, and the outer edges are moving a lot. So that's a standing wave. The cool thing about standing waves is that they're kind of everywhere. It's not just springs that you see in labs. You also see it quite a lot with sound. And when you have a standing wave that happens in the air with sound, you end up getting this nice resonance, and you'll be able to hear it a lot more. One way to show it really clearly is I've got this pipe sticking out of a graduated cylinder of water so that the water cuts off the pipe. So I can kind of change the length of this column of air by raising and lowering the pipe. So what I do is I take this tuning fork, which rings a very specific frequency, in this case 440 hertz. If I hold it above this and get it just the right length, oh, you hear it? Doesn't really happen down here, not up here, but right there, at just the right length, it resonates, and that's a standing wave in the air. Physics is also the study of electricity and magnetism. And for electricity, I want to show you something that's pretty cool. This is called a Wimshurst generator. And what happens when I turn this crank is that a huge amount of positive charge is going to build up on one of these little spheres in the front, and a huge negative charge will build up on the other. And if I build up enough, you get these nice little lightning bolts. Those bolts end up being tens of thousands of volts, but if you stick your finger in between there, it's not going to kill you. I'm not going to do it because it hurts, but one thing that we can look at when we look at electricity is the fact that voltage isn't the one factor that tells you that it's a big amount of electricity that's going to kill you. There's a lot of other factors that go into it. So this one's always fun because sometimes people do stick their finger in there and they're fine. Let's take a look at some magnetism. What I have here is a coil of wires, which is hooked up to a power supply. I'm going to turn on this power supply, and something that happens with coils of wire is that when they have current going through them, they end up behaving like an electromagnet. So what happens here is that I can then pick up this nail with, actually no, it makes a very, very poor electromagnet. So what we have to do is to add in a piece of iron. This has some magnetic properties. It is not in and of itself a magnet. It won't pick up the nail. But if I put the iron into the electromagnet, now it'll pick it up. But if I turn off the power, it'll let it go. Another thing that physics is the study of light. Light often involves working with lasers. These are actually lasers we built for the classroom. Building stuff is one of my favorite things about teaching physics, getting to build the things for the classroom. And so lasers are kind of interesting. They're going to send light into a very, very, very direct path like this. If I shine it at the camera. Very bright, very powerful. But in physics we get to look at things like how lasers work and what their properties are and what kinds of things they can do. One more thing that is included in physics is the study of relativity. And relativity is one of the weirdest concepts that I dig into in my classes. Maybe the weirdest, probably the weirdest. And the way I show this is just by showing a meter stick. A meter stick is pretty intuitive. It's a meter long. But it turns out, if you were to send this meter stick traveling very, very quickly, like close to the speed of light quickly, I can't throw it that fast, but if you were to send it traveling that fast, the meter stick would not be a meter long, it would actually be shorter. And it's not just length, it's time too. What I mean by that is, if you travel very, very close to the speed of light, time will pass differently for you than it will pass for people who are at rest with respect to you. That is very weird, but it is true, and that is relativity. And those are all the things you study when you study physics, but what is physics to me? It's a completely different way of seeing the world and explaining things around you. It's a different way of thinking about math and problem solving. It's a different way of understanding what's going on in the world around you. And as you study physics more, sometimes you start to see it everywhere. Your view of things start to change. It can also be frustrating at times. It's really hard to get a good mastery of physics. Sometimes it's just so weird, it twists your brains in knots, but I think it's very worth it. I think it's very exciting. It's one of my favorite things to talk about, and that's physics.